Hi, welcome to this video. In this video I'm going to demonstrate the JAL HC-SR04 library for the PIC microcontroller, which is programmed with the JAL programming language. And this HC-SR04 is a module that is capable of measuring distances. So what will be the contents of this video? First, a short introduction. Then I'm going to give a description of the HC-SR04 Ultrasonic Distance Sensor module. Then I will show some signal measurements that I did on the oscilloscope. Then the functions provided by the JAL library. I will show two schematic diagrams because I am going to demonstrate two setups. Then in the demonstration you will see both setups at the same time. And at the end of this video you can find the references. So the HC-SR04 is an ultrasonic distance sensor module. And the JAL library will measure the duration of an ECNO signal that's returned by the module. And this ECNO signal is then converted into a distance. And in this demo I will show the operation of the library, and I'm going to show two setups. One is the connection from the module via the PIC to a serial interface or to the PC, and the second one, the PIC is connected to a LED bar. So the HC-SR04 module operates at an operating voltage between 3.3 volts and 5 volts. It uses a 40 kHz ultrasonic sound to measure the distance. You can activate it by a trigger pulse which must be at least 10 microseconds. Then it will return an echo signal, and the duration of this echo signal determines the distance. And the range is between 150 microseconds and 25 milliseconds. So the measuring distance is about 2 centimeters to 4 meters, and the accuracy is about 0.3 centimeters. So here you see a typical measurement. So the yellow line is the trigger pulse and the blue line is the echo signal. The response time is around 2.2 milliseconds. You can see that in the next picture. So this is one measurement. You can't see the trigger pulse always, but it's very short, it's 10 microseconds. The echo signal is about 180 microseconds, and this is a distance measured of about 1.9 to 2 centimeters. Another measurement, of course it starts with a trigger signal. The echo signal is 856 microseconds, and this equals a distance of about 15 centimeters. And the last measurement, here you can see the trigger pulse again. The echo signal is about 16.6 milliseconds, and this equals a distance of about 287 centimeters. So the library generates a trigger signal, and it will measure the echo signal that is returned by the module, and for this it will use a timer. And by default the timer is running at a frequency of 1 megahertz. And the echo signal is measured in the background and is using an interrupt for that. So this means that your main program is not disturbed by the measurement. And you can select two types of interrupts. You can select the external interrupt of the PIC microcontroller, or you can select one of the interrupt on change pins. And the library is quite simple. It only has a few functions. First you have to initialize the library so that it will also initialize all the interrupts. You can start a measurement, and once a measurement is done it will indicate that a new measurement is received, or it will indicate an error. And an error can happen when a measurement is out of range. And then there are some functions that will return the measured distance in millimeters or in mil. I'm using two setups for this demo. This is the first setup, a PIC microcontroller connected to the serial interface of a computer. In this case the PIC is running at 20 megahertz. The second setup is the PIC is controlling a LED bar. And so if you are close to the sensor, the only one LED will be on, and the further you go away the more LEDs will be turned on. and in this case the PIC is running at 32 MHz. As said, what I mentioned before, two setups are demonstrated at the same time. So the first one, the serial interface, and you will see the distance on the screen, which is measured twice per second, and the distance will be shown in millimeter, in mil, in centimeters and in inches. And the second setup will use the LED bar, and this measurement is done once every 100 milliseconds. The modules are facing backward, and that is, otherwise they will disturb each other's signal. So here you see the setup. On the right side you see the interface with the serial setup, and on the left side you will see the setup with the LED bar. So I'm going to switch them both on at the same time. And what you see is the distance measured by the serial one. So I will move my hand towards, and you can see the distance is changing. If I'm further away, the distance will be quite long. Then I will go to the LED bar. I will change the distance, and you can see more LEDs are turned off. If I'm too close, all are off. And this blinking means that there was a measuring error. So I hope you like this demonstration. If you want to know more about JAL, you can visit the JAL website. There you can download the JAL packages, the compiler, the libraries, the sample files. And if you want to get started, you can also have a look at the video Getting Started with JAL. If you have questions on how to use JAL, there's a very good JAL tutorial that you can download from the JAL website. You can also visit the JAL's Google group and you can post your question. If you find bugs in JAL libraries or the JAL compiler, or you have specific requests, you can post them in the JAL Lib Google group. And all the sources can be downloaded from GitHub. I hope you liked this video, and thanks for watching.